Welcome back to Voltage Learning. Let's walk through this Intel analog engineer question because it touches on a very common bring-up issue that trips up even experienced designers. The question asks, during bring-up, an op-amp configured as a voltage follower shows an output that rails high even when the input is at mid-supply. Which condition most commonly causes this behavior? At first glance, this can feel confusing. After all, a voltage follower is supposed to simply mirror the input. But the key insight here is that negative feedback only works if the op-amp is operating within its valid input range. Even though the circuit uses feedback, the op-amp's input pins still must stay within the device's input common mode range. If the input voltage exceeds that range, often because the op-amp is not rail-to-rail on its inputs, the internal input stage can saturate. When that happens, the feedback loop effectively breaks down. The op-amp can no longer regulate properly, and the output often slams into one of the supply rails, frequently the positive rail during bring-up. Now let's briefly rule out the other options. High open loop gain is normal and expected. It doesn't cause an output to rail by itself. Slew rate limits how fast the output can move, not where it settles in steady state. And a lighter output load actually makes it easier for the op-amp to drive the correct voltage, not harder. So the correct answer is, the input common mode exceeds the op-amp's valid range. This is exactly the kind of issue that shows up during early lab bring-up and silicon validation. Intel interviewers like this question because it tests whether you understand that datasheet limits still apply, even in seemingly simple configurations like voltage followers. If you want analog explanations grounded in real-world debug scenarios, not just textbook theory, that's what Voltage Learning is built to deliver.